Now, transformer mechanism, energy transfer, how it happens, we'll see. Step 1, electrical to magnetic. AC voltage applied to primary, current flows through primary conductor. In primary conductor, current will flow. Current creates magnetic field around the conductor. Okay, Faraday's law, just don't forget. Then multiple turns, multiple magnetic fields. One turn, one magnetic field. Two turn, two magnetic field. Three turn, three magnetic field. So multiple turns, multiple magnetic fields. Now what happens to that magnetic fields? In step 2, magnetic concentration in iron core. Iron core concentrates magnetic field. It will concentrate. It will take all the magnetic field. And what will it do? It will do flux density increases 1000 to 5000 times versus air. Okay, we have seen in 7th standard that iron powder, and we have seen the magnetic lines in air. Now it has got medium. Medium is this core. Flux density increases in the core 1000 to 5000 times. It is crazy. It's very good conductor of magnetic flux. So it will increase, and that is what we require to transfer the energy from primary to secondary. So from it is times air. Okay, whatever magnetic flux is flowing in air, it is 5000 times, up to 5000, from 1000 to 5000. Magnetic field follows core path from primary to secondary. Core path, simply. Very little flux leaks outside the core. Very little flux. Now in step 3, now it is transferred to secondary. It has come. It has created. It has come to secondary. What happens in magnetic to electrical? Changing magnetic flux passes through secondary turns. These are secondary turns. Changing magnetic field will passes through this. Then what will happen? Each turn generates small voltage. Each turn, 1 volt, 2 volt, 3 volt, 4 volt. Each turn will, let's say, create 1 volt. Then it will become 4 volt. So it depends on the turns, number of turns. So all turns voltage add up to total secondary voltage. Add up. I told you 1, 2, 3, 4 volt. Okay. Then voltage magnitude depends on number of turns. Simply, if you increase the turns, the voltage magnitude will go up because it is adding up. Now, step 4, what happens? Now it has generated the voltage. Now, electrical output, secondary voltage drives current through load. Now, this secondary voltage will push, this is the energy, right? The energy will push the current through the load. Load is connected to the secondary terminal. These are secondary terminals. Load. It will drive the current through that. Load current creates its own magnetic field. This load current will create this current. Whatever current is flowing, it will create its own magnetic field. And it will oppose. See, secondary magnetic field will oppose primary magnetic field. It will oppose it. But it is very smart. What happens? Primary automatically increases current to maintain flux. It will become more stronger, and that is how current will increase. Current, and that is how it will draw more current, because to maintain the flux, it has to maintain the flux. So it is very smart. It will maintain the flux, and that is how we will get more current into secondary. In the same way, in the primary, current will increase. Now, see, this cycle repeats 50 times per second for 50 Hz or 60 times in 60 Hz. Now, energy conversion stages. Now, input, electrical energy, primary. Then stage 1, electrical to magnetic. Magnetic transfers through iron cone, then magnetic to electrical, and electrical energy output to secondary. Simple. Now, why this method is so efficient? Why? Ask me why. So no physical resistance like conductors. There is no physical resistance, and we have seen it is so highly efficient. 1000 to 500 times more flux can be conducted through iron core or silicon steel stampings. So iron core, extremely efficient magnetic current, magnetic conductor, no moving parts, no friction, no mechanical losses, minimal heat, only small resistive losses in winding, very small, because it's a copper winding. The resistance is very less. Then direct conversion, no intermediate energy forms. Direct conversion from magnetic to electrical. Then energy loss breakdown, copper losses I square R, 1%, only 1% copper losses, because energy in winding is copper. Okay. I square R losses we have seen. I is current flowing through the winding and R is resistance of the winding. It is squared. Then core losses, that is why we are bringing down the current to transfer it, because I should be lesser. Again, I am telling you. Then core losses, hysteresis plus AD. I told you both the losses in last lecture. It is only 0.5. Then stray losses means magnetic flux is leaking to the outside through the air. That is stray. Stray means moving here and there. It's like stray dogs going here and there. That is only 0.3. Total losses 1.8%. Efficiency is 98.2%. Okay, it is a highly efficient device. Now, if you compare transformer, see, is highly efficient, then magnetic gearbox, then power electronics, and then electric motor. So transformer is, there is no moving parts. That is why it is 99.5% highest efficiency. Then what? This mechanical gearbox. Then what? Power electronic converter, and then electric motor. Okay, this is the comparison. Now, key insights. What are the insights? Transformers are the most efficient electrical machines ever invented, most efficient, because they use pure magnetic coupling with no moving parts. Pure magnetic coupling with no moving parts. This efficiency comes from the direct conversion of energy through magnetic fields without mechanical components, resulting in minimal losses and exceptional performance. Okay, so this is, now we'll see timing cycle visualization in 50 hertz and in 60 hertz. Here only one thing to note. See, in 50 hertz, 1/5 of a second, 50th, okay, 50 cycles in 1 second. Now, one cycle, how much time it takes? 20 milliseconds, one cycle in 50 hertz. Just note this, 20 milliseconds one cycle takes, because 1 divided by 50. Here it will be 1 divided by 60, and it will take 16.7 milliseconds. Okay. So each cycle represents a complete energy transfer through all 4 stages of the transformer operation. Okay, in this way we have seen what is the difference in no load transformer and fully loaded transformer. What happens exactly inside the transformer. Okay, in next lecture we will see very interesting part. So stay tuned. Okay.